In this lesson on counting methods and probability, we're going to talk about combinations. So recall before we talked about permutations. The permutations were used when we had a particular group of people or things or objects or events, and we want to figure out how many times those events or people or objects could occur in a particular order. Well, with combinations, we're just trying to find out how many times that group of people can occur or events can occur, not necessarily considering the order that they're in. So let's review when to use combinations. One, when we want to find the number of ways an event or thing or group things can occur. And two, when the order of occurrence is not important. So let's use an example to differentiate between combinations and permutations. Let's say I have 5 guys who are running a race, and I want to figure out how many combinations there can be of groups of 3 of those 5 gentlemen, and then also how many permutations there can be in groups of 3. So I have 5 gentlemen, as I mentioned, John, Jeff, James, Jasper, and Jeremiah. And I choose just one combination, which would be John, Jeff, and James. And in this case, it doesn't really matter what order they come in. It's just one combination. Now, when we talk about permutations, order matters in this one group of people. And I can rewrite these 3 names in 6 different ways. They can come in 6 different distinct outcomes. So John, for example, could come in first, Jeff could come in second, and James could come in third. Or Jeff could come in first, John in second, James in third. Or John in first, James in second, Jeff in third. So we can, when order is important, we can see that there are more permutations than there are combinations. In this case, the ratio is going to be 6 permutations to 1 combination. So let's figure out exactly how many combinations there can be of these 5 gentlemen and how many permutations there can be of these 5 gentlemen if we were trying to find subgroups of 3. So recall the formula for combinations is we take the number of possible things or events in that group, and we want to figure out or choose a certain number, which we call R. So the total group number is n, and the number or subgroup that we're choosing from that larger group is called R. And that equation is going to be n factorial over n minus r factorial times r factorial. And the number of permutations is going to be that same group choosing the same number. Again, order is going to be important. And that equation is n factorial over n minus r factorial. And you can see the difference between the two is that in the combinations case, the r factorial is going to be included as part of the denominator. In the permutation case, it's not. So let's go back and figure out what that answer might be. So in the combinations case, I have 5 individuals, and I'm going to choose 3 of them. So I would rewrite this as 5 factorial over 2 factorial times 3 factorial. And if you do the math, you'll come out with 10. In the case of the permutations, it's going to be, again, 5 people. I'm going to choose 3. Order is important. And I write 5 factorial, which is my n, over 5 minus 3 factorial. Remember, I don't include the 3 factorial here. I'm left with 5 factorial over 2 factorial, which is equal to, if you do the math, 60. Now this makes sense. 60 is 6 times as great as 10. And remember when we did the example here, we had 6 for one combination, we had 6 permutations. So this makes sense. Now let's make things a little bit more difficult, and let's choose an example from your textbook, number 13. How many combinations of face cards can there be? Well, let's think about this. First, if I had a deck of cards and I wanted to figure out, I had all day to figure out how many different combinations there were. What I would do is I would take out all the kings, because that's a face card, all the queens, and all the jacks, and I'd put them all together. I have 4 of each. That gives me 12 total. Then I'd choose that set of 12, and I try to find out how many sets of 5 I can generate. So in this case, it's going to be 12 individual cards, and I'm going to choose 5 of them to figure out the combinations. So it's going to be 12 factorial over 7 factorial times 5 factorial. Again, if you do the calculations, you should come up with 792. In the next example, we're going to talk about, we're going to make this even more difficult. We're going to talk about how many combinations of at most 1 queen we can generate from our 52 cards in a 5-card hand. Well, if I think about this closely, I know that there are going to be combinations in which there are no queens, because it says at most, and there are going to be combinations in which there is just 1 queen. So let's just isolate the combinations where there are no queens. So again, I think about this, I have the deck of cards in my hands, and I try to figure out how I can manage counting the number of combinations of cards, 5 cards, that don't have a queen. The first thing I'm going to do is I'm going to take out all the queens. Well, I know there are 4 queens and there are 52 cards in a deck, so I'm left with 48 cards. And out of those 48 cards, I'm going to choose 5. So this is your equation for the number of combinations where there are no queens. Now it gets a little bit trickier. If I want to choose the number of hands that have just 1 queen, then what I do is I take out all 4 queens first. I take out all 4 queens, and then I'm just going to choose one of those queens. And then after I choose one, I'm going to multiply it by the rest of what's left in the deck, which is 48 cards. And now, since I've already chosen one, I only have 4 more to choose. I'm going to choose 4. So I've got 2 possibilities. I've got a possibility where there are no queens, the possibility where there is 1 queen. And I'm going to add those 2 together. And if you do the math, you should come up with 2,490,624. In the final example, we're going to talk about how many combinations of at least 1 spade there can be. Okay, now this is a little bit different. Before we said at most 1 spade. Now we're going to say at least 1 spade. So in this case, we say, well, how many spades do we have? Well, I've got, spade is a suit. There are 4 suits in a deck. I've got 52 cards in a deck. So if I'm going to pull out 5 cards, I'm going to pull them out of a total of 13 spade cards. Okay. Now, there are going to be possibilities where I have, if it's at least 1, I'm going to have possibilities 1, 2, 3, 4, and 5. Okay? So I go back to my example with the queen, and I say, okay, let's just pull out all of the spades, and we'll separate the deck into 2. In the first case, I'm just going to choose, of those 13, I'm going to choose 1 spade. And then I'm going to multiply it by what's left over. I have 39 cards left over, and I'm going to choose 4. And then I'm going to add that to a case where I choose 2 spades, so I have the 13 spades, I choose 2 of them. And I'm going to add that, or multiply it by a combination of 39, choose the number of cards I have left, which is 3. See, these total the 5 cards that I'm choosing. And I continue this process on 13, choose 3 spades, and I have 39 cards. I choose, 2. I have 13 cards. I choose 4 spades, and I have 39 cards left. I choose 1. And I have 13 cards. I have 13 cards. I choose 5, and then this is just going to be 1. 39, choose 0. Now you could go through the process of figuring this all out, and that's well and good. But there's actually an easier way to do this. If you think about it closely, there are 6 different possibilities, actually. I can choose 0 spades, 1, 2, 3, 4, and 5 spades. I'm looking for 5 cards. In the case I have 0 spades and all the rest non-spades, 1 spade and 4 non, 2 spades and 3 non, and on and on. So what you can do to make this simpler for yourself is to say, okay, what I'm going to do is I'm going to figure out how many sets of 5 cards I can choose. And then I'm going to subtract the one case in which I don't have any spades at all. Right? So that would be 0 spades. And the formula for 0 spades, right, is going to be, well, I have my deck of 13 and I pull them out, and all I have left is 39 cards. So of those 39 cards, I choose 5. So this equation tells me how many combinations of 5 cards have no spades. And if I do the combination work this way, I only have to deal with 2 equations versus, I don't know, this is 10 different equations. And they both come up with the same answer, but this one is far simpler. And if you do the math, you should get 2,023,203.